Hello, Tube Timers. Today is going to be a great day on looking at this amplifier. As you can see here, we have our amplifier. It's under test right now. And in order to do the testing, we have an HP 8903B analyzer. Connected to the equipment, we have a Tektronix 2465B scope and a very old HP netbook that runs Windows XP that has to be used to run the software. Okay, what are we doing today? Today we are going to establish baseline responses, test responses for our amplifier. And the reason I'm doing this is to determine the impact that our modifications are going to have upon this amplifier. Hopefully, our work will yield something halfway decent, but this will give us an idea of what we've done better or worse. Before we get started, I want to show you an input-output signal on this amplifier. I'm using a 1 kilohertz test signal, which is very common in the audio industry. And I wanted to take a look at the VU meter response. Now, what does that mean? All right, permit me to move this camera around and my thing out of here. And there you go. This signal is the input to the amplifier. It's approximately 0.28 volts. The reason why I selected 0.28 volts is to provide a 1 watt signal to the load bank so that we're exercising the amp a little bit and we have a load that I can repeat. The other signal is the output. Now it's kind of curious. If this is 0.28 volts, this is 2.8. So as far electrically, our amplifier is creating a gain of 10. Now, let's take a look at this lower signal. I want you to note that the negative half of the sine wave is clipped. Positive looks good, but the negative has got some clipping. Now, let's take a look at our VU meter. Our VU meter is showing, I'm going to amplify that a little bit, is showing that we're just into the red zone. So this is what you would expect. You would expect to start to see clipping or the VU get into the red zone when the clipping has just started. What I'm going to do right now is just take it down to a little lower volts. Perhaps 0.35. So bear with me while I use my fat fingers on keyboards. I'm going to put in 0.35 volts. And we'll take a look at our output amplifier. And just by going down a half of a volt, we have a nice clean output signal. Of course, the input signal is clean and the output signal is clean as well. So it's rather interesting that this amplifier begins clipping about 0.38 volts. Okay, let's kind of get into it. Let's talk about this HP 8903 device. I can enter the frequency and the amplitude, and it will give me what the output voltage is. And if I press a distortion level, I can see that at 0.35 volts, I believe, we're getting 3.6% distortion. So that's not too bad for tube amplifiers. Tube amplifiers like this are not instrument amplifiers. In instrument amplifiers, this would be completely unacceptable. Instrument amplifiers are used for test equipment and measuring signals that need to be reproduced accurately. Okay, that kind of gives you an idea about this fella here. Now, what we're going to do this morning is take a look at this software that was created by Pete Millett. He's got an excellent website, and he happens to have software that drives the 8903, and we're going to determine the frequency response. So I've pre-programmed this device so that the frequency response will, how can I say, perform as expected. Cheating maybe? Not really. It is the response of the amplifier. So what I'm going to do now is put this phone back down so that you can kind of see what the equipment does, more or less. And what's going to happen is I'm going to start at 20 hertz. This equipment will, Pete Millett's HPIB software will run this device from 20 to 50 kilohertz, and we're going to see what the frequency response is. Note the scope jump around as it goes through frequency changes and the amplitudes associated. Finally, up here on top, we'll see the frequency response curve displayed. So, without further ado, let's get underway with this test. Oh, perfect reference level. And off we go. Let's watch the scope do its thing. I know, it's like watching paint dry, but you're going to see it proceed through the frequencies. And you can see, since I had it set for 1,000 hertz, the lower frequencies are really stretched out. And you can see those frequencies begin to increase. I've got 10 points per decade from 20 to 50 kilohertz, so it takes a few seconds. In the meantime, you can kind of see the scope, the device running through. That's 1200 hertz, 1590, 2000 hertz. And of course, with the higher frequencies, the scope's running closer. And we're done. I hope you could hear the screaming of the transformer and tubes as it was getting up into the higher frequencies. This is not a good thing, but it's acceptable. All amps have a tendency to do it. Now let's take a look at our frequency response. And what a nice thing this is. The frequency of our response of our amp, this is 20 hertz. See if we can zoom this in a little bit. There we go. This is our 20 hertz. This is 100 hertz. I have to look at it. 1,000 hertz. Look how nice and flat that is. And it begins to roll off around 20 kilohertz, which is within the manufacturer's specification. So truly, this is an excellent frequency response for this particular unit. That's nothing to be ashamed of, that's for sure. Marvelous software, this. Otherwise, I'd have to go through and enter the frequencies by hand one at a time. And let me tell you, that is tedious. Okay, so the amplifier the test is completed. The information is displayed. And that's a very interesting part. Perhaps that's enough for today. I've been dying to tear into this thing and see what it looks like inside. So, ToobTimers, that's all for now. We'll have some more detail in the future. I'll have to investigate to see if I can have files associated with my YouTube account, because if so, I have several graphs that I'd like to publish on this amplifier. It's important to note, and this is incredibly important when you look at amplifier specifications, that the specifications are explained with what the test conditions were to develop the spec. For example, if I have a high frequency, do we still have a flat curve? If I increase the power, does the power continue to provide harmonic distortion that's appropriate? Oh heck, let me take a look at the Give me a moment, please, while I reconfigure the software to get another type of reading out of the device. Bear with me for one moment. This was our frequency response. Now I think what I'd like to do is power. We're going to take the power coming out of the amplifier, and we're going to say, okay, for given power, what's our harmonic content? Somehow we have a tendency to think that at half a watt, 1 watt, 10 watts, the harmonic distortion remains the same. Not so. And this is very important. So when you look at an amplifier's specifications, you should ask yourself, I wonder where they ran these tests, and do they have a curve that shows the amount of distortion we're adding by increasing or decreasing the power. So if you would permit me, I'm going to set this up. We'll go to 5%. We're going to use the same test frequency of a kilohertz. We're going to put in 10 points per decade. And level, excuse me, that is a voltage. So we're going to go to I'll go to 1 volt, and we'll see what goes on with it. Let's go nuts. 1.5 volts, because that's the most you're probably going to get out of a preamp device. Our maximum total harmonic distortion, we'll call 7%. And that's random. It's what I want to do. I think we've got everything set up. This is unrehearsed, so gosh knows what's going to happen. It's actually working. The software works good. The operator has a problem, generally. So what it's doing is at 1 kilohertz, you can kind of watch it on the scope, and permit me to do this. You'll see the input. This is the input voltage. This is the output voltage. And it's increasing. And notice the distortion starting up with us. Nasty distortion. Oh, now we're getting positive clipping. That is the clipping response. So this ought to be kind of interesting when it's done. Oh my. Oh my. Okay. So at 0.1 volts, we have 1.2% harmonic distortion. With a 4 volt input, we're up here to 3.5% distortion, and then after 2.1 volts, it just breaks down. The thing just collapses after 2.1 volts. So here you can see as the harder you're driving your amplifier output, the more distortion you're getting. If you did that with your own stereo, you'd probably notice it as kind of just a blatting sound. It gets kind of nasty to listen to. That's what you're hearing right there. All right, tube timers, this was a complete wag, but it ought to be kind of fun. I hope you enjoyed this session. And please, if you like this, please subscribe, because I'm going to continue to get into this amplifier. And if you subscribe, you'll watch me tear it apart and make changes. Now, I have this information saved, so we'll be able to go back and I can tell you what it was before and what it is after. Have a great day, tube timers, and we will see you later.